Very good evening, students. Welcome to Jatadhara Educational Technology Program, and this is a coaching classes conducted for Nmms exams 2024-25. So, in today's topic, we are going to deal with mathematics, numbers. Numbers are the real magics in our life, isn't it? All right. So now, before we go ahead, let us first know about the natural numbers. All right. So the numbers used for counting are called as natural numbers, right? So numerals are used to represent, that is to write the numbers, natural numbers. So what are all natural numbers? It starts from 1, 2, 3, 4 until infinity. That is till whatever number exists. So these are actually called as the natural numbers. All right, now in this, let us know what is whole numbers. So the natural numbers and 0 put together, right? So the natural numbers and 0 put together, it is called as whole numbers. So your whole number starts with 0, 1, 2, 3, and so on till infinity. Am I clear? So whole numbers means your number starts with 0, 1, 2, and so on. So natural numbers means 0 is not there. It is only 1, 2 until natural numbers. 1, 2, 3, 4 till infinity numbers. All right. Now let us see integers. So these are all the basic terms that we all must know. All right. So if required, you all can note it down so that this can be served. This will serve you for a quick reference. All right. Now, let's move on to integers. So whole numbers and their negative version of the numbers put together, it forms the integers. All right. So earlier we saw the whole numbers and before that natural numbers. So whole numbers is nothing but it comes with 0. Whole means 0. Okay. All right. So natural numbers is done. So in this integers, you take the whole numbers and their negative version, which means 0, 1, 2, 3, 4, 5. And before that, -1, -2, -3, -4, like that. Is it clear? So whole numbers along with their negative form also is considered for the integers. All right. Now let's move on to the property. Closure property under addition for natural numbers. All right. What is it? It is the closure property under addition for natural numbers. If we add any two natural numbers and the sum is also natural number, obviously because all are natural numbers, isn't it? So natural numbers is except 0. So 1, 2, 3 and so on till infinity. Of course, this property says if we add any two natural numbers and the sum is also natural number, then we say closure property is satisfied by natural number under addition. So let's quickly pick up the examples. So 2 is a natural number, 5 is a natural number. When you add 2 plus 5, we get 7. All right, so because 2 is a natural number, 5 is a natural number. By adding two natural numbers, we end up in another natural number. So closure property is satisfied by natural numbers under addition. So let's try some more examples. Right? So as I said, let me use another color. Right. So as I said, natural numbers starts with 0, 1, 2, 3, so on till infinity, isn't it? So your closure property, you can add any natural number 2 plus 3 is going to give you another natural number 5, isn't it? Next, you take 11 plus say 12. This is also natural number, which is going to give you 23. This is also a natural number, right? So here in this slide, you would have understood that two natural numbers are added and you will get the third also as the natural numbers. Any natural number, infinite natural numbers, if you are going to add it with infinite natural numbers, your resultant figure will be a natural number only. That is what our closing closure property says. All right. Yes. Now let's move on to the next one. Closure property under addition for whole numbers. So whole numbers, what did I say? For whole numbers, it starts with 0. 0, 1, 2, 3, and so on till infinity will be your whole numbers. All right. So if we add any two whole numbers and the sum is also whole number, then we say the closure property is satisfied by whole numbers. So earlier we saw that the closure property under addition, right, for natural number. Here we are seeing the closure property for the addition under whole numbers, for whole numbers, right? For example, we are taking 0 plus 8 is 8. So 0 is a whole number, 8 is a whole number. So your resultant figure is also going to be a whole number. All right. So closure property is satisfied by whole numbers under addition. So let us try some more examples. Okay. So let's take a whole number to be 0 and another whole number to be say 365. So what do you get? Of course, you get only a whole number. So this is also a whole number. This is also a whole number. So this is an addition property, isn't it? Property under addition. So here also you get the result as the whole number. All right. So take another whole number as 11 plus another whole number is going to give you 11, which is a whole number. Right? Yes. So one more example, same 12 plus 0 is going to give you 12, which is also a whole number. If I'm going to put another instead of 0, if I'm going to put 12, we get 24. So this becomes the natural number also. All right. Yes. Now let's move on to the closure property under addition for integers. Right. So what did we see for integers? If we, before that, integers, what we saw was 1, 2, 3, 4, 5, and the negative 1, -1, -2, -3, -4, and so on. Right? So these numbers, we saw it under integers. Now with this understanding, let's move on to the closure property under additions for integers. If we add any two integers and the sum is also an integer, then we say closure property is satisfied by integers under addition. All right. For example, you see here, -5 minus 4 is -9. So -5 is an integer, -4 is an integer, and the resultant figure is also -9, which is an integer. So closure property is satisfied by integers under addition. Let's try few more examples. Right? So let's take -6, -6. We get -12. So -6 is an integer. Again, -6 is an integer. So -12 is also an integer. Let's take -3, -2. So we get -5. So -3 is an integer. Minus 2 is an integer. Therefore, the resultant of minus 5 is also an integer. All right. So I'm sure the closure property is satisfied by the integers problems would have been understood when it comes to addition. All right. Now let's move on to closure property under multiplication for natural numbers. So what did we uh, discuss about natural numbers? 1, 2, 3, 4, and so on till infinity, isn't it? If we multiply any two natural numbers and the product is also natural number, then we say closure property is satisfied by natural numbers under multiplication. For example, 2 multiplied by 5 is going to give us 10. 2 is a natural number, 5 is a natural number, so 10 is also a natural number. So closure property is satisfied by natural numbers under multiplication. Let us try few more examples. Okay. Here goes. Natural numbers 2, 7. Closure property under multiplication. So 2 multiplied by 7 is going to give me 14. This is also a natural number. This is also a natural number. And when multiplication is done, again we get the resultant as only natural number, right? Yes. Next, let's try 5 multiplied by 3, which is also a natural number. Is it clear? One more. 9 multiplied by, say, 3 will also give us the natural number. So that is why closure property is satisfied when these natural numbers are used in the multiplication. Is it clear? I'm sure you would have understood this concept, students. With this, let's move on to the next question. Next topic. Closure property under multiplication for whole numbers. Right? So whole numbers we saw 0, 1, 2, 3, and so on till infinity, isn't it? So if we multiply any two whole numbers and the product is also whole number, then we say the closure property is satisfied by whole numbers under multiplication. Clear? So one example, 0 into 8 is 0. Right? So closure property is satisfied by whole numbers under multiplication. Okay, so let's try few more examples. All right, so you should always know any number multiplied by 0 is going to give us 0 only. Any number multiplied by 1 will give us that number. So now let us take the closure property under multiplication. So 0 into 2 is going to give us 0. This is a whole number. This is a whole number. This is also a whole number. Another example, 10 multiplied by 0 is going to give us another whole number. So 10 is a whole number. 0 is a whole number. The resultant figure is also a whole number. So closure property is satisfied when this whole numbers means 0, 1, 2, 3, and so on till infinity. So when this whole number is used under multiplication. So one more, 0 into any number till infinity is going to give us only 0. All right, students. So I'm sure you would have understood this. Now let's move on to the next question. Closure property under multiplication for integers. So if we multiply any two integers and the product is also an integer, then we say that the closure property is satisfied by integers under multiplication. Right? For example, minus 5 into 4 is minus 20. So minus 5 is an integer. 4 is an integer. Therefore, minus 20 is also integer. Now, closure property is satisfied by integers under multiplication. Let's try few more examples. right? If you take minus 10 into, say, 3 is going to give me integer. So this is integer, minus 10. 3 is also an integer. The resultant figure is also an integer. Let's take minus 3 into minus 3. So 3 3s are 9. Minus into minus is going to plus. So going to become plus. So minus 3 is an integer. Minus 3 is an integer. The resultant is also an integer, right? Next, minus 7 into 2. Minus 7 is an integer. 2 is an integer. So the resultant figure is also an integer. Is it clear? So I'm sure you would have understood the closure property. So it gets satisfied under multiplication when the integers are used. All right. Yes. Now, closure property for natural numbers under subtraction is not satisfied. Right? Yes. So when you say that the closure property, one second. Yeah. So closure property for natural numbers under subtraction. Right? So when do you say that the closure property for natural numbers under subtraction is not satisfied? Right? So here we can give an example. So natural numbers, you can take it as, just a second. All right. Natural numbers are just, let me use my pen. It is 1, 2, 3, and so on till infinity. So no zeros there, no negative figures are there. So closure figure for natural numbers under subtraction is not satisfied. Example, we can take 3, which is a natural number, and 5, which is a natural number, right? So when we are going to subtract 3 from minus 5, the resultant figure is minus 2. So minus 2 is not a natural number. That is why we say that it is not satisfied. Yes, let's try with few more examples. Minus 10 plus 1 is going to give me minus 9. Right? So minus 9, again, see minus 10. Plus 10. Let's take this. Plus 10 minus 11. Okay. So 10 is a natural number. 11 is a natural number. So here I am going to do the subtraction. So 10 minus 11 is going to give me minus 1. Again, minus 1 is not a natural number. That is why we say that it is not satisfied. One more example, 9 is a natural number, right? Next, 12 is a natural number. But when I'm subtracting one natural number with the smaller natural number with the higher natural number, I get minus 3. So, which is not a natural number because it is coming in negative. So, we say that it is not satisfied. All right. So, this is a closure property for natural numbers under subtraction. All right. Now, closure property for whole numbers under subtraction. Right. So, what did we say for whole numbers? Yeah, whole numbers are nothing but 0, 1, 2, 3, and so on till infinity. So closure property for whole numbers under subtraction is also not satisfied. For example, when we take two whole numbers, 0, 3. So these two whole numbers are being subtracted. What happens? 0 minus 3 is minus 3. So minus 3 is not a whole number. Therefore, we say that it is not satisfied. Another example, 0, okay, and say 5. So we are subtracting 0 minus 5, which is going to give me minus 5. So again, minus 5 is not a whole number. Therefore, we say that it is not satisfied. All right. So thus we can say that the closure property for the whole number under subtraction is not satisfied. That which means that your resultant figure is not going to be, it may not be whole number. Yes. Next, closure property for integers under subtraction, right? So even the closure property, so here integers, right? So here integers, what are integers? We say 1, 2, 3, and so on. And on the other side, we have minus 1, minus 2, minus 3, right? So it goes like that. So closure property for integers under subtraction, even that may not be satisfied. Yes, just a second. Let me change the pen. Yeah, fine. It's okay. So let's take another example. So when the integers, when you take the closure property for integers under subtraction, for example, minus 1, right? So minus of minus 1. So what it becomes? It becomes minus 1 plus 1, which is 0. So that is, this is one example that we can definitely consider for this closure property for integers under subtraction is not, it doesn't satisfy. All right. Next, yes. So here, right. So I think it's already time. So we'll do this commutative property for natural numbers under addition in the next class. So with this closure property for integers, for whole numbers, for natural numbers. So these things are to be revised, students. So I'm sure you would have understood. So we'll meet you in the next class. Thanks for watching, and do not forget to subscribe to our YouTube channel, Jatadhara Educational Technology. Right? Just a second. All right. So there's an announcement to be done, students. So please stay on the line.
So, yes, students, as you already know, that we have said that on 15th we have mock test, right? Nmms exam mock test. So, for that, registration is compulsory. And స్టేట్ గా చాలా మంది రిజిస్టర్ చేసుకున్నారు. సో ఇంకా ఎవరైనా రిజిస్ట్రేషన్ చేసుకునే వాళ్ళు ఉంటే డిస్క్రిప్షన్ బాక్స్ లో లింక్ ఉంటుంది. యూ కెన్ రిజిస్టర్. ఓకే, దట్ టుమారో we have exam and we will update you. Okay, so bye everyone, and again we will meet on Monday evening 8 o'clock. And the registered students will get test link tomorrow. And don't forget to subscribe our channel Jatadhara Educational